Folks, Sega fan here. This is a follow-up to my Composite and S-Video RGB decoder. That video actually has quite a few views. I think it's close to 1,000 now, which is really surprising because I didn't think anybody else cared about this kind of stuff. I've been doing these kind of hacks for a really long time, and only recently has it come into vogue, I guess you could say, to do RGB mods to old gear. And the idea for this, by the way, is I have an RGB modded CRT, and in doing that mod, I had to give up the S-Video and Composite inputs. Now, I could actually go back nowadays with my current knowledge and skill set and probably hack it to add those, but it's more work than it's worth, especially because the monitor weighs hundreds of pounds. It's a 36-inch CRT from 1994, and it takes 3 people to lift the thing. So I'm not about to go hacking that right now. It's much easier to hack a board like this to convert a composite input or an S-Video input to RGB and adjust it through this board. I don't have the remote control for this. It would be great if I could find that, because then it would really have many of the functions of a full TV. Not as high of quality, of course. I'm sure the OSD settings are very basic on this. In fact, I know they are, but still pretty cool. One of the things you want to look for when you're doing hacks like this is 2 chips like this in the LCD area. Because this is old school. This is before everything was super integrated, and this is like early 00s, maybe even late 90s. These IR3Y chips. There's the IR3Y31 and the IR3Y26. I believe it's by Sharp. Yeah, these are by Sharp. And if you can find anything with this chip, you're in luck. You can do some cool hacking with it, because that chip will take composite and S-Video inputs and convert them to RGB. You also have this chip, which is a TFT controller, and that the fact that these are separate means that this is old. Everything nowadays incorporates those 2 in one chip. And so this is the digital driving chip that takes the analog RGB signals. Though I guess it might actually make them... Does it make them? It makes them DC coupled, but they're still not digital. Yeah, that's what it is. So this will take analog coupled inputs, make them DC, and this will take the DC coupled inputs and make them digital. However, what's really interesting about this particular unit, and I have not seen this in any other unit, is that this also has another composite and S-Video decoder. I'm not sure why it has 2. I'm guessing it's using the IR3Y for additional settings for brightness and aperture and stuff like that, because this particular chip has fewer settings. This is the TDA8361. I've never seen this chip in anything else. It looks like a dinosaur, giant dip chip. But it's really cool because it's a much easier version to work with of the IR3Y chips. I don't know if it's from the same era or not, but it's basic. It's really easy to hack, and that's what I like about it. This will take a composite CVBS, aka CVBS, or S-Video input, and make it... This actually has 2 crystals stacked up on top of here, so this particular version I believe will do PAL or NTSC. I think it's hilarious the way they stack the crystals up there. You can see the 2 symbols on the board, and it has a multiplexer as well, and that's a 744053. That's a common analog multiplexer. It's a 2-to-1 multiplexer with 3 channels. So what that means is that you have 3 inputs, and those can be selected to have between 2 different outputs for each of those inputs. What does that look like in the real world for this guy? Well, that means you have composite, audio left, and audio right, and you can have 2 sets of those, and it will select them and send whichever one you've selected to this amp based on your input. And so that's why you have this breakout connector that used to be here that would actually run through the opening. This is now a composite jack, but this used to be an opening that this thing would pivot on, and so the wires would run to this connector. Wherever the wires ran to, you know, some buttons or whatever, some kind of interface that would let you multiplex those analog inputs. Now, you can see here I've already hacked this thing, and that's why, you know, I talked about it in my previous video from some years ago, but I've learned quite a bit more since then, and I really didn't know exactly what I was doing back then. I just remember trying to get the proper levels of the output for the RGB. And I just had a hell of a time. And this is using a TH7314, very common chip for an RGB amplifier. There's a buffer, essentially. Though might not actually be necessary. It doesn't hurt to buffer your outputs. Definitely can help most of the time. But what's interesting is I actually rigged up some trim pots here to try to find the values myself in connection with the ground resistors that are already in place. There were previously 2 onboard trim pots that were not helpful at all, just because like you need 3 to really do things effectively. But in examining the datasheet more and understanding more about it, this thing will actually output RGB that is DC coupled, of course. It doesn't have capacitors in the output, so it'll be DC coupled from the chip. That DC coupled RGB output will need a voltage divider for each line. And this is the part where I really skipped over, is that the datasheet will actually tell you, it tells you what that voltage peak to peak is, and it's 4 volts. 4 volts. So all you have to do is a voltage divider calculation to determine how to make 4 volts into 0.7. 0.7 is what all TVs basically use. And so when you give that 0.7, you feed it to this buffer. This is a 6 dB gain or a gain of 2. And so that will take that 0.7, make it 1.4. Then when it connects to your TV, which is 75 ohm terminated, that will bring it back down to 0.7. So the question is, how do we get that 4 volts into here at 0.7? Well, you have to simply do a voltage divider. So you do a series resistor of 4K7 and a resistor to ground of 1K. Those are the calculations that I came up with. I believe they're correct. I'll go ahead and give them a shot, and I'll report back in a future video. But I believe once I do those calculations, obviously get my output capacitors in place. The inline capacitor output right now is like 150 ohms. I did this all wrong before. Right now it's set at about a 2.5 volt input. And then so the output's going to be close to 5 volts peak to peak. With 150 ohm resistor, so that's, you know, not standard either. It's supposed to be 75, and so no wonder my image is like really washed out and weird. You know, I've been dealing with it, but I decided to crack this open because Composite's bad enough. You don't need to make it worse. I'm also going to be adding the S-Video functionality, which I've been wanting to do for years. I've been sticking with Composite because this is just a backup anyway for stuff that doesn't already have an RGB mod, which is few and far between in my house. But yeah, that's pretty much what's going on. What else is going on under the hood here is you have a microcontroller, and this interfaces with the remote sensor, which is on the front here, right there. And this board, you can see that colorful wires that come out there. That interfaces with the button interface. That's a serial interface. I don't know if I can call it serial. It's one of those interfaces where you have a resistor in parallel with each, or sorry, in series with each button press. So it kind of, I guess it kind of serializes it in a weird analog way. And then of course your remote infrared input. I would love to figure out how to hack or program a remote. I do have a universal Logitech remote control that is programmable. So if anybody has any ideas on how to do that, I'm sure some of you Arduino programmers out there would have a thought or two on how to recreate a remote control for this thing. I'd love to hear it, because that would be super sweet, because then I can sit on my couch and adjust brightness, contrast, hue, all that kind of stuff. And I'll even have an onboard OSD, because this thing has an OSD as well. The other thing that I'm adding to this time around is an RGB output. The reason why I'm doing that is because, again, my hacked RGB TV, I can't adjust any settings on it. Looks great, but I can't adjust anything. I'd love to turn down the brightness just a smidge. And I'm hopeful that, I'm sorry, this is the RGB output. I mean an RGB input. I'm hopeful that I can use this RGB input tied to the chip, because it actually has RGB inputs, to accept RGB signals from consoles that are already modded, and then use this chip essentially as an OSD controller and a brightness controller, because it has a built-in clamp and controls for that. Now, whether or not the brightness controls actually affect the RGB levels, maybe not. I'll have to check the block diagram again. I believe they do, but I'll double check. But yeah, that's pretty much it. It could be cool. Oh, one last thing, actually. This also accepts and outputs R minus Y, B minus Y, and Y, which are used for component. I'm not sure if they're the exact component standard of PB, PR, and Y. I need to learn some things about components still. I barely ever use it. Everything I have is RGB these days. But there was a time when component was really important, and I'd like to learn more about it, because if I can add component inputs and outputs to this thing, that would be really sweet as well. And ideally, this would just be an all-in-one RGB monitor, you know, board that you could just plug into any RGB monitor, 15 kilohertz, of course, and have all your inputs ready at hand with a remote control. It's almost like a mini, I don't even know what to call it. I guess it would just be a decoder. A decoder converter could also be a transcoder of sorts with other additional features. So this is kind of a cool hack. I think it's pretty cool. Hopefully you find this interesting, and hopefully I haven't just garbled a bunch of information in your face that you don't understand. I know I'm talking kind of fast, and this is some of this can be a little complicated, but I'm just trying to get the information out there. Hopefully this was useful to somebody. And if you find any more of these boards for sale, I really don't see them very often. It would be cool if you could let me know. And if you find a way to hack this for a remote control input, even some leads on how to do that would be very interesting. Also, note, this incorporates an audio. I don't believe it's the amplifier, but it does have audio control circuitry, which the IR3 3Y26A does not have. So that is one significant difference. I really hate it when audio circuitry is mixed in with video circuitry. That always causes problems with interference. So I might even ground the audio inputs on this thing. I really want to not use audio at all. But you can see that's why there's this speaker here, and there's, I believe this is a mini speaker amp, and so that's controlled from this guy as well. Pretty interesting chip. It also runs off 8 volts, which is really weird. You never see stuff that requires 8 volts as a supply voltage. But there you have it. Very strange chip, interesting board. Also, you have all these drills here in the back. That's to ventilate heat from the inverter, because the backlight uses a cathode tube. So interesting stuff going on here. Pretty cool stuff, fun to hack. Yeah, I guess that's all for this video. This is Sega Sonic Fan, signing out.